turn on my PowerPoint and get started. And I know it was kind of a lot, the introduction, but really what my team does is we are out across the state in all forests, not just our state properties, but we're out in private forests, other land groups, other nonprofit owners, and seeing what is actually going on. Like when we see tree damage, what's actually causing that? What are the major trends we're seeing in our forests, and what mitigation actions we can actually take to help improve our forests? Also, before I dive in, I will say I am not a Massachusetts native. I pronounce every town name wrong, so do not take it personally as we go along. I still, after a few years here, I still haven't caught on. But I've really enjoyed my time in Massachusetts, and as part of my job, I get to get out and see a lot of the state and also talk with a lot of groups like you guys. My team is pretty small, so we can't see every tree, we can't be everywhere. So we always love the chance to share information about what we're doing and what to look out for. We always welcome emails and calls from people that have questions or see something weird out in the forest. So at the end, I'll have all my contact information, but don't ever hesitate to reach out to us, even if you think it might be a silly question. We love to hear from people. And I'm going to dive in, and I'll start by saying our forests here in Massachusetts are pretty young. In the 1800s, we were cutting down trees. We were clear cutting this Commonwealth. Trees were being used for products like building homes and building industry, out for you guys in the coastal areas, building ships. And then a lot was just cleared to create farmland. A huge amount of grazing was done by sheep. And by the 1860s, about 80% of the state was clear cut. So we removed 80% of our forests. So in the last 150 years, our forests have only really started to come back and grow. And what we see now as big trees are really not that old on the scale of what a tree's lifespan can be and what a forest's lifespan can be. And the trees that I have returned and grown up in these last century did develop alongside much more human development than the centuries before that. So we went from these pretty wide open barren landscapes to a state now that is absolutely covered by trees. We have trees growing everywhere, even in areas where we have pretty dense residential areas and urban growth. We still do have quite a bit of forests. I think now so in the 1800s, we're only about 20% tree cover in the state. I think now we're in the high 60s, so like 68%. So we do have a lot of trees in our state. And how we approach forest health and what the future for these forests look like is really changing now in the face of climate change. So how to protect your trees are the right answer. It can be challenging because we are going to expect changes to what we have seen and what the conditions our forests have developed under. And the big ones we're really expecting to see here in Massachusetts are warming temperatures. So we're going to see warmer winters. So insects, diseases that might not have survived our cold winters before will now be able to survive that. Also, some of our tree and plant species, they do require those dormancy periods in the winters. They like to get cold, and that really helps them in their natural life cycle processes. So warming temperatures is going to have direct and indirect effects in the winter. We're also going to have a lot hotter summers, so we're going to have warmer temperatures. Some of our trees don't really like to be that hot either. And with warming temperatures, we're also going to see longer growing seasons. So our last frost is going to be earlier. Our first frost is going to be later. So we're going to have a longer amount of time that trees and plants are going to be growing, longer amount of times that our insects are going to be active. So it's just temperatures throughout the year is going to have a huge impact on all of these different complex organisms that work together in our forests to create this ecosystem. We're also going to see some altered precipitation patterns. So overall, over the course of a year, we're not going to expect to get any more or really any less rain, but how we're receiving that rain is really going to change. So we're going to have longer periods of drought and then get like events that are much more severe. So getting more rain in a shorter amount of time, which then leads to things like flooding. So our trees will have fighting against drought and then fighting against flooding periods of time. We're also not expected to see as much snowpack in the winter. This last winter, we had snow, it melted. We had snow, it melted. For you guys out on the coast, that's a little bit more normal for you, but out in my area, it's not as usual for snow not to last, at least during parts of the winter. So having changes to snowpack, changes to snow melt in the spring, really influence the insects themselves and the trees themselves, but having differences in how we're receiving rain influence things like our funguses that can get into trees. And with those changes in precipitation, we're going to have more storm events. So there's going to be more frequent storms and more severe storms. In the last few years, we've had a number of tornadoes here in Massachusetts doing damage. And while our tornadoes are luckily much smaller than those like out in the Midwest and in the plains, they can be quite devastating to people's homes. People have unfortunately passed from storm events in the last decade here in Massachusetts, and they're quite destructive to our forests. And for you guys out on the shore, we're going to see sea level rises, which will then change habitat. We'll see changes in our marsh and wetland habitats, and those kind of intertidal zones that have these really unique wetlands and marshes, and those types of forest types you see out there will change as the sea level rises within those areas. So here, a lot of my work focuses around invasive insects and how they are influencing our trees and forests, and they're nothing new. We've had invasive species being huge problems for over 150 years. And the way we've really approached these has changed as new species have been introduced, how our ability to fight these things, the tools we have to be able to use have really changed a lot. And our management and focus have really, like over the years, we have quite a bit of change. And one of the big tools we use in my team for identifying what's going on in our forest is an annual aerial survey. So we get in a tiny little airplane with nowadays it's with tablets, and we mark any of the damage we see out in the forests. Then my team goes out on the ground and actually sees what was causing that damage. And we've been collecting aerial survey data for a very long time. So starting in the 1930s, we had some periodic data. But since the 70s, we've been very consistently collecting data and being able to see in a good snapshot what is going on in our forests across the state. And as time has gone on in the history of what we see, the pests, the diseases, the insects, what we're seeing changes from year to year. And we've gone through phases of having certain species that have been huge problems, and then it's really kind of died out and we don't really see them anymore. We've had some that keep coming back cyclically through our forests. And a lot of this has been influenced by our forests themselves growing up and changing. So some of these things, our forests have grown and developed. They've become older, more resilient, more diverse. So some of the native insects, and we're not seeing quite as much. But we have new invasive species that have come in and become larger problems in that amount of time. The way we approach problems has really changed. Like I'm not spraying DDT across the state anymore, which really influences how some of these defoliators work on our things. We also sometimes we capture abiotic things. So things like when we do have tornadoes or winter injury or other so abiotic is non-living things. So a lot of these weather events will impact our forests, but it's really cool to go back through the data and look at what actually has changed in our forests and what's still here. And as you've seen, there's been a lot of areas impacted. There's been a lot that's going on, and it's kind of crazy that we still have so many trees and we still have so many healthy forests despite having all of these events going on over the last century. So this is my map from last year, and you can see there's tons of different colors, a lot of different things going on. It's very hard to read in a small scale, but I'm going to share in the chat our story map for our forest health program, which has some more information about some of the insects I'm going to talk about and some of the work my team does. But there's also an interactive map where you can actually zoom in closer and see this a little bit easier, because this PDF is not super great to share. So this is our story map. And it only has last year's data, but another really cool tool is a forest health atlas, which is a regional data set of all of the historic aerial survey data throughout New England. So you can search by year, by location, by specific pest if you're looking for that. So you can look in your area and kind of see what's been the big issue that's been going on in the last few years, or what was the big issue when I was a kid. Then I remembered seeing something weird going on with my trees. So it's a really fun one to play around with. And so this is through the Forest Ecosystem Monitoring Cooperative. They have a bunch of other really cool tools on their website for the region as well. So some climate change predictions and modeling, and they house some of our historic documents as a regional initiative as well. Okay. All right, so I'm going to start jumping in and talking about some of the specific things that we see, not just in Massachusetts, but out in your area. And in the last few years, one of the biggest one has been the Lymantria moth. So this used to be called gypsy moth. It is now called spongy moth. So it recently underwent a name change. There's a group called the Entomological Society of America, and they're in charge of all common names for insects here. And they made the name switch just a few weeks ago. So I'm still getting used to it. I might slip up, but it is now spongy moth. And it's not new. It's been here since 1869, and it has been a pretty severe problem since soon after its introduction. So it was widespread in the state by the 1920s, causing severe defoliation events, and has caused quite a bit of tree loss. It has a pretty wide host range. It'll eat a lot of different trees, but it really prefers our oaks. So most of the time when we have these big outbreaks of it, we see damage in our oaks first, but when there's huge populations and they're very hungry, they'll move on to things like even our pines, our hemlocks. And the way we used to approach it is way different. They would climb those trees with no harnesses, scraping egg masses. They would paint arsenic and creosote over egg masses. We would spray all sorts of chemicals out of airplanes and trucks and horse-drawn wagons, which we really don't do any of that anymore. We much more allow natural controls and processes to keep the population in check. And it does, since it has developed and grown with our forests, there's predators, parasitoids, pathogens that go after the spongy moth. It does function a bit more like some of our native insects do. So it's been naturalized to our forests, where we don't do this type of approach in management anymore. And you can kind of see we did have cyclical outbreaks. We have that really low period of time in the 50s to the 70s, and those are the years we were spraying DDT. And when I read the old reports, they're like, we sprayed it and it was great. We saw nothing. It killed them all. It was such a good job. We're the best. And it did kill the spongy moth, but it did also kill a lot of beneficial insects in our forest, and bioaccumulated and impacted things like our raptor population. So thankfully, we stopped using that in the 70s. Unfortunately, we did have big spongy moth outbreaks in the late 70s and early 80s. But since then, we've kind of seen smaller impacts until we kind of hit 2015 to 2019, where we had a widespread defoliation event in central and eastern Massachusetts. I know that your forests out there were decimated. I'm sure you all remember hearing what sounded like rain on a nice sunny day, but really it was just the caterpillar excrement falling from the leaves. So we did see quite a bit of tree mortality. So this was in 2019. So after a few years of defoliation. And then we also had a very severe drought in 2016. We saw a severe decline and loss of oaks throughout the state. It accumulated in about 70,000 acres of oak mortality. And when I say 70,000 acres, it's not that every tree in 70,000 acres died. That's usually it was about like 10% of trees within that. So we still had oaks, we still have trees, but we did have a big loss of trees. And in forest, processes like this can be at times beneficial. So when you do have older trees or really even aged and even species dominated stands, sometimes events like this can open up pockets. But at points where it is very severe, it can be jarring to the ecosystem. And it is a burden on homeowners and communities to handle these hazardous trees along roadways and near structures and buildings. So it is unfortunate that we had such a large outbreak event and did see this, but luckily in 2019, our population decreased again, and we have not seen any signs that it's building up again in the eastern part of the state. Berkshire County, Franklin County, they are seeing a bit of spongy moth population increase now, but you guys are good out there. And like what causes those populations to rise and fall? So one of the biggest thing is a fungus called Entomophagum omega. It is a very host-specific fungus, so it only really activates and kills spongy moth caterpillars. So it rests in the soil the rest of the year when spongy moth are not out, and then in the spring when the rain conditions and it's those nice cool wet spring days, it becomes active. The spores then land on the spongy moth caterpillars, it penetrates into them and kills them. It is its own living organism. It has its own requirements to be successful and live. And we have dry springs. It is not really good at infecting the caterpillars. So we had dry springs in 2015 and 2016, which limited that fungus's ability to control the population, which is why we saw a huge population boom. Other things like just the general, if it's too cold or it's too hot, sometimes the gypsy moth caterpillars won't feed properly and we'll see increased mortality. They have a virus that goes through their population. It's called NPV. But as we all have learned in the last 2 years, you need to be in close contact to spread viruses around. So it's only really impactful when they have very large population numbers. The virus will kill off quite a few of the caterpillars. Birds will sometimes eat them. They're pretty hairy and gross, so they're not super palatable. Mice actually eat a ton of the egg masses. So that's one of the bigger controls when the population levels are kind of low. Mice will keep the population low. So when we have these, like last year, we had a huge acorn year. So we have a big mast year for our oaks. So when those acorn numbers go up, the mice level goes up, which then the more mice are eating the spongy moth egg masses, so those numbers go down. So we do have a lot of controls in the population, but with climate change, we don't really know with our changing precipitation patterns and our warming springs, if they'll be as successful at keeping the population low the way we were seeing in the 90s and early 2000s, or if the event we saw in 2015 to 2019 will become something more regular once again. So this is what we kind of saw last year out in Berkshire County. So we are seeing defoliation, but we go out and look at egg masses every year. And luckily for you guys up in the North Shore, we did not see any egg masses at all, really. We saw very few numbers. So it will hopefully be very low once again. Other caterpillar defoliator species have been a big problem up in the Northeast as well, including winter moths. So early 2000s, it was a very severe problem, far outshining spongy moth. And it is an early season defoliator. So it actually starts feeding before the leaves start emerging. So as soon as buds start breaking, it'll start feeding. And it's these tiny little inchworm caterpillars. And since it's hitting trees so early, they're not even getting a chance to push those leaves out. They're not even getting a chance to start photosynthesizing after that long winter. It can be really damaging to the health of trees. Luckily, a biocontrol species, so researchers from UMass Amherst and the US Forest Service released this fly. It's Cyzinus albicans. So it is a parasitic fly, and it puts one of its eggs inside of the winter moth caterpillars. And the winter moth caterpillars will then drop into the soil and pupate while that parasitoid eggs inside of it. And inside the pupae, it feeds on them and emerges again as a fly. So it is a amazing population control. It has decimated the winter moth population. So much so that we actually haven't detected any of it since 2014. So it is now considered minimal risk. We may have years here to here where we do see pockets that kind of have a buildup, but this fly has become well established. It's been able to spread on its own. So we do think winter moth will be sort of a minimal problem going forward, hopefully. This brown-tailed moth is another defoliating moth that was introduced in, I think, 1905 in Massachusetts. So an early invasive species problem, but it also became naturalized pretty early. So it had a different parasitic fly, it's called Compsoglara, that became established, and it also had funguses that controlled the population. And we haven't seen it really being problematic since the 1930s here in Massachusetts. So it does prefer coastal areas, coastal trees like shrubby oaks, beech plum, cherries, things like that. But up in Maine, they've had a huge population increase over the last 5 years, and it just seems to keep growing. So we have been surveying down here. This time of year, you see them as they'll be in webs on the end of trees. So if you look out on the end of trees, they'll be like these nice silvery webs. But we have not been seeing an increase in our population here. It is always here, it's always endemic, but it's very low level because we've kind of had this control methods. In the past, when they used to have areas that had a lot of the webs in winters, they would just burn the trees down. We don't do that up in Maine. They do web clipping, so they'll clip off the specific web ends of branches, but we no longer are lighting trees on fire as a control mechanism. And this can be destructive to trees, but it does also have a human health concern. So the hairs on the caterpillars are really irritating. So they can blow on the wind and get on you and cause rashes, or if you're up close and breathe them in, it can have respiratory irritation as well. So if you see webs on trees, don't touch them, leave them alone. When you're out at the beach, don't cut across dunes and through the brush, kind of stick to the trails. Because we do have them here, it's just very low numbers, so it's low chances of coming across them. But our changes in precipitation and temperature will kind of change how these different moth populations function on our ecosystem. So what we're seeing now might not be what we're seeing in 10 years. Some of our native insects, so we have native, so the ones I described were all introduced, but we have native pests that function really similar. So one called fall cankerworm, that's a really early season defoliator, similar to winter moth, has become a really big problem out on like Nantucket right now. We have things like forest tent caterpillar and eastern tent caterpillar that feed around the same time that spongy moth does and have similar hosts. Also sometimes goes through outbreak events. So some of our native insects might also be changing as precipitation, temperature change, because they have other parasites, predators, temperature requirements in their life cycles as well. And out in your way, you don't have as much hemlock as some of the interior stands, but you still do have some, and it has been a popular planted tree in yards, but hemlock woollia delgid is a big problem on them. And it's actually a teeny tiny little insect that feeds right at the base of a needle. But as it grows, it pushes out this waxy substance that looks like white little fuzzy balls underneath so if you flip over the needles, you'll see these fuzzy like little white spots. And they're piercing sucking insects, so they have little mouth parts, they feed right in there. And when you have so many of them on a tree, it really starts to stress a tree out, even though they're so little. And we've had it here since the 1980s, so nothing new, and we've definitely seen decline in hemlocks, but we do still have plenty of trees, and part of that is they don't survive our winter temperatures very well. So when we have cold winters where you have those really like negative temperature days, like a week in a row, will wipe out their population. They also don't really love when temperatures fluctuate a lot. So the days where it's like 40 degrees and then 10 degrees and then 30 degrees and then 0 degrees, those rapid temperature fluctuations will also knock back their populations. So we luckily have had it here since the late 80s, but we haven't seen as much damage as some of the southern states have, because we do have cold temperatures that kind of keep them knocked back down. Unfortunately, it is, so it's referred to as a parthogenic bivoltine population, which means it is an all-female population that has 2 generations in a year. So you only need one single one to survive the winter to build that population back up. So in 2018, we had a cold winter. We saw some sites we could not even find adelgid. But now, a few years later, with a few mild winters, we are seeing huge numbers again, because they just can really rapidly build up again, because they have those 2 generations per year, and the females can just produce eggs and keep the population going. They also move really easily. So since they're so small, so light, they can blow on the wind. They get on birds really easy. Birds, hemlocks are a great habitat for birds, but unfortunately, birds, they can spread the adelgid around. So even if a stand lost every single hemlock woolly adelgid, a bird could come in and reintroduce it. So it is it's very challenging to fully eradicate from sites, and we just know that it's here in Massachusetts, and it's present throughout almost all of our hemlock stands. We have tried to release biocontrols. So these are little beetles that actually just eat the adelgid. So they go along under eating eggs, eating the adults, just eating the population. But they also have a hard time in our winter. So we haven't had very good luck having them established here, because the winters are a little too harsh for them. And also their food source fluctuates so wildly. So we are still working on it. We recover beetles here and there, but we do not see as much luck as the mid-Atlantic and southern states do in having these biocontrol beetles. These are all the sites we've released at, and we really don't find them at many of them. A lot of our hemlocks also have elongate hemlock scale, which is another invasive insect. It's on the underside of the needles. You'll see these flat kind of ovals that are like kind of brownish. And it's called an armored scale. So it's pretty durable and tough, and they are a little bit hardier to our winter temperatures. So we don't see the populations decrease as much as the adelgid populations do. So the sites we're seeing the biggest decline and loss of hemlocks now are sites that have both elongate hemlock scale and hemlock woolly adelgid, because they're kind of not getting that break in those colder years, because the scale is just kind of a consistent pressure that keeps pushing through. So when we do treat in some of our really culturally or ecologically significant stands on DCR properties. We choose a product that kind of kills them both, because it is becoming a pretty severe problem in most of the state. So these warming temperatures will alter our insect population. So we have invasives that have not been huge problems now, but might become bigger issues as our winters warm, as our summers warm, and we might become more suitable habitat to species that weren't previously able to establish here before. So we could have new species being introduced that before would have just died off, but now we'll be able to establish and damage some of our trees. So we're always keeping our eye out for weirder things, sudden decline, stranger damage, and early detection is really the most useful tool against new species introductions. So emerald ash borer is another introduced beetle. So this is actually a wood boring beetle. It feeds just right under the bark in the cambium layer. And as it feeds, it ends up girdling a tree, and it's no longer able to move nutrients and up and down through the tree, and that's what ends up killing it. And we have found it through most of Massachusetts. It's been widespread. You guys out there are still white on that little map. But part of that is you don't have a huge ash component of your forests. You do have some ash planted. It's a pretty common street tree. Like you'll find it in outside parking lots and in little median strips, but it is not as big of a coastal component of the forest. So it's not that it's not present in your communities, it's just that we haven't detected it yet. So if you do see damage from it, please feel free to reach out to us and report it. We like to always check it out and add it to our detection maps. But as it gets into trees, you'll start to see the canopy die back. So you'll see branches not leafing out in the spring. You'll see branches starting to fall off. The larvae feed right under the bark, and they are a great food resource for woodpeckers. So this time of year, one of the biggest tools we use for identifying new infestations is looking for woodpecker damage. So woodpeckers will have been feeding all winter, and we try to get out and look before leaf on when it's really obvious. So as the woodpeckers damage, they make like these really ragged holes, but when they're scooting up and down the tree, they kick bark off too. It's called blonding, but you'll see those lighter patches of tree. And then when you actually peel back the bark, you'll see these nice S-shaped serpentine galleries where the larvae have been feeding. And it usually takes 2 to 3 years before you start to see the canopy die back and some damage from having emerald ash borer. And within 5 to 6 years, you'll see most of the trees start to decline and die. And ash become very brittle very quickly. For those of you that like to burn firewood, they're great firewood because they dry out really quickly and they're very light and don't bring a lot of water to your fire. But it does mean that they become more dangerous more quickly and they're more hazardous to remove. So if you do start to see your tree declining, it is better to get it removed quickly before it is actually totally dead. Some people do preemptively remove ash even before they see the signs. And if sometimes it's in your best interest just because it is safer to remove at that point and you know that it will eventually get to there. Sometimes in forested stands, we encourage people to leave your ash, see what happens. Dead trees can be really good habitat for wildlife. But when it's like next to your house, along roadways, along sidewalks, near parks, it just poses a risk that's really not worth it to kind of to see when it happens. We do release biocontrols for this as well, and luckily these are much more successful. So these are parasitic wasps, and it looks like they have stingers, but those are actually called ovipositors, and they put their eggs, so the two on the left put eggs directly into the EAB larvae under the bark, and the one on the right puts an egg into the EAB eggs. And these they're surviving, they're spreading and establishing here. Unfortunately, these won't save this generation of our trees. So they are becoming established on the landscape. They'll be a useful tool against EAB as it becomes naturalized to our landscape. But they're really going to be the most useful in the next generation of ash that returns. So as these trees die out and we have the next generations of trees going up and the next wave of EAB coming through, these biocontrols will really be useful at keeping some component of ash on our landscape in the long term. We try to get these out in all of our counties where we've had detection, so pretty widespread across the state. And it's part of a national effort. So we get these from a rigor lab from the USDA out in Michigan. And I think they've released in 35 states now. So the goal is to get them throughout the range that's being impacted by EAB. And there are areas, so EAB first came from the Midwest out in Michigan, and they've done a lot of research in the areas it's gone through now, and particularly in their white ash stands, they are seeing trees survive. So trees that have been infested and still survived, or trees that were able to avoid getting infested. We're a little bit still a few years out from being able to survey and identify that here in Massachusetts, but that's kind of our next phase, is going through our forests and ash resources and seeing how well our ash actually did, and if we have populations of lingering ash and what we can do to promote that genetic stock. One of our newer diseases is beech leaf disease. So this impacts American beech, European beech, and ornamental beech. So both our forested trees and our planted landscape trees. And it first occurred out in Ohio, and it's a very, very new disease. So it was only identified 10 years ago, and it's already spread all the way here to Massachusetts. And we have found it in 6 counties. We've unfortunately found it out by you guys, but this has only been since we first knew it was here in 2012 when we got our first report. So it is likely in many more communities than this, but this is just where we've been able to find it in the last 2 years. And it is actually caused by a foliar nematode. So things like wood boring beetles, bark beetles, defoliating caterpillars, they're really common pests. They're common across different types of trees. They're common in different forests. They're common across the world. But foliar nematodes are really rare. Not that they're foliar nematodes, they're common, but a pathogenic foliar nematode is really rare. It's rare in any plant, but it's almost unheard of in plants. Like, it's not really a plant issue. So it actually took them 5 years from first identifying this disease damaging trees in Ohio to figuring out that it was a nematode causing it. They're very small. How they cause damage is kind of unknown. They don't really know if the nematode also has a bacteria or virus associated with it. But it's definitely different. It's hard for me to give advice to communities that we've identified it in, because we don't really know how it's spreading. We don't know how it's moving through trees or how quickly the disease is going to progress. But we do know it is very easily identifiable. So if you stand under a beech tree on a nice sunny day and look up, you'll see these dark bands between the veins on the leaves. So it'll start when the infection's new. You'll see just a handful of leaves that have like 1 or 2 stripes. And as it progresses, you'll see like more and more bands on more and more leaves. And it even happens on the different beech color morphs. So you'll see sometimes like those coppery or purple leafed European beech, they'll also have darker bands that form between them. And the symptoms are present as soon as the leaves come out. So they're happening, the nematodes are in the buds during the winter. And so when the leaves come out, they'll have the stripes. Really, ones that are like heavily damaged will be dropped earlier in the season, because the way the banding is, it's damage to the tissue. So they're not great at photosynthesizing. So it's not valuable for a tree to hold on to them into the growing season if it has a lot of damage. But the ones that have those minimal, just a few stripes, you'll see them through leaf drop in the fall. You'll be able to identify the damage is. But as the disease progresses, leaves will come out. Eventually, they'll just come out like weird and curled and shriveled. But they don't feel like papery or thin. They actually feel like thick and leathery when they come out. And eventually, buds won't push out leaves, so you'll have some canopy dieback. And it can eventually kill trees. So it's possible to kill seedlings and full-size trees, but we don't really know how quickly it's going to progress here in Massachusetts. We have established long-term monitoring plots. So my team's out in currently infected and uninfected beech stands, monitoring symptoms and overall tree health to see what it's actually going to do to our forests. And it's part of a regional effort. So all of the other New England states are participating as well, to see how it's going to impact our New England forests. We do also have beech bark disease. So we've had this since the 1950s, really common here in Massachusetts. And it is a combination between a scale insect that feeds on the bark that introduces a fungus, which then causes cankers. This only impacts American beech, so most of our forested beech. So we have lost a significant component of beech already in the 20th century, but it is a little bit slower. It's not as consistent. We see pockets here and there. So we don't know how it's going to impact both beech bark disease and beech leaf disease on some of these trees. And talking a little bit more about diseases is our eastern white pine decline. So I'm sure you've seen like just our white pines are just not looking super great in the last decade. And it's throughout our state, but actually throughout the whole region that white pines exist. So from Georgia all the way up to Maine and out to the Great Lakes. And most of this is being caused by native funguses. So these are fungal pathogens that infect the needles when they're elongating. So they get into the needles, then the second year that it's been in a needle, they'll drop. And most of the common funguses we're seeing cause discoloration and then early needle loss in like June. So in May and June, you'll start to see really like yellow looking pines, and then they'll drop a bunch of needles. So they'll kind of look really dull in the early season and then kind of thin through the summer as the newer needles are elongating. So a white pine usually holds on to needles for 3 years. But with these fungal diseases, they're losing their second and third year needles a lot of the time. So they only have their first year needles. So they're surviving, they're getting by, but they're not being able to photosynthesize as much as they normally would. They're not being able to grow as rapidly as they would. They're not being able to store as much energy as they used to be able to. So they're not quite as resilient to other stressors as a white pine typically would be. So you're just seeing trees that are thin and not looking so great, but the needle cast itself does not actively kill trees. But when we're flying in the aerial survey, it's pretty easy to pick out. We try to target our flights for mid-June to see our big defoliators and also to see this white pine needle disease. But we see it in almost all areas of the state. A lot of our white pine stands are seeing this. And these are native funguses, but why did it suddenly become more prevalent now? And it's kind of a two-parted thing. And the first is climate change. So we're getting some different spring conditions, different weather patterns, different precipitation patterns in the spring that allow these funguses, but also changes in the age, structure, and management of our forests. So our white pines are getting all to they're pretty even aged. They're getting to be over 100 years old, and they're very crowded. They're all really dense on each other. So when they're really dense and don't have a really good airflow, it allows those funguses to kind of keep moving on. It keeps it kind of moist within the canopy, and it allows these kind of native funguses to become more prevalent than they have traditionally. We also see other kinds of funguses. So Calixiopsis, it is a bark canker that we see on white pines, and it's associated with this little best scale insect. But when these form, they form kind of like weeping long cankers on a tree, and we'll see it on any size class. It's pretty noticeable around that same time in June. You'll see it'll look like kind of glistening down a tree as some of you'll see running from as the cankers weep. And on a larger tree, it doesn't really matter that much. The cankers are small compared to the general size of the tree. They might impact a little bit of timber value, but not the overall health of the tree. But it's really in our very thick seedlings and saplings where we see the biggest issue with them. Since they're so much smaller, a canker can really impact them because they don't have as much girth of cambium to flow nutrients through. And it does kill some of our seedlings and saplings, but part of this is it's part of a natural process. Not every seedling is going to make it to be a big 100-foot tree. They do need to naturally thin out. So it is funguses like this that thin these out. Climate change and sometimes site conditions do a little bit more aggressive thinning, and allow the fungus to establish a little bit better than probably it traditionally should. But that doesn't mean that it's abnormal to be seeing things like that. It is kind of abnormal, and we're seeing more decline in mortality in trees that are just having these fungal pathogens and additional stressors. So like pines along roadways that get salt damage, pines in sites where they're getting really impacted by drought, or where a neighborhood was built and their hydrology of the site changed and now they get much more wet than they used to. Trees don't like being too dry or too wet. So we do see some loss of pines, but we're really seeing not whole stands and really not big forested sections. It's more individual trees or small pockets where the site conditions are just a little bit more stressful, and it allows secondary invaders, so things like bark beetles and wood borers and other native insects to come in, or root funguses to kind of take hold in those trees. I do want to mention white pine blister rust. So this is actually not a very big problem here in Massachusetts. They put in a lot of effort in the 20th century to work on eradicating it from the landscape. So rust species need two different hosts. So they need a primary host and an alternate host. So the primary hosts are white pine. The alternate hosts are trees in the ribes species. So these are things like currants and gooseberries. So they put in so much effort and so much money to remove rabies species from the landscape. So without the alternate host, it's not able to complete its life cycle. It's not able to impact white pine. And it is becoming a little bit of a concern because growing currants is a little bit trendy. There's been a push in some communities to increase their ability to grow. So towns, it's on a town by town basis for approval. So towns can decide if they want to be able to grow. So they can only grow gooseberries and red currants. You cannot grow black currants here in Massachusetts. But the gooseberries and red currants still are able to spread the disease. So we do keep our eye out in case we do see any pockets of it. Luckily, I've only seen it once while working here, and it is very rare on our landscape. This is a great tool, like the University of Maine, researchers from other states and the US Forest Service worked on this really cool manual of common issues with pine and some silvicultural management options to help improve the health of your pine stands. And it is a little bit swayed towards the Maine perspective, where they do a bit more timber harvesting than we do down here in Massachusetts and managing for that. But it is a really cool guide. And I don't have it pulled up to share a link, but if you Google it, it is easily to find the PDF of it. So what does the future hold for our forests here? We do expect new invaders. We do continue to get new invasive species. That just this year, we've identified spotted lanternfly in Massachusetts, in Fitchburg and Shrewsbury. That is a little bit more of an agricultural pest, an urban forest pest, but it does feed on some of our trees. It loves tree of heaven, which itself isn't invasive, but it does feed on things like grapes, in orchards. It does feed on red maple, sometimes rose bushes. So we are expecting to have new invaders introduced. We do expect to see an altered impact of our established invasive species, as well as an altered impact to some of our native species. And as the climate changes and we go through these droughts and have these increased storm events, those are stressful to trees, and those stresses can build on pest issues from native insects or other things that normally wouldn't have negatively impacted a tree, but now with this additional stress, we may see decline more commonly. Damage to trees and storm events can also be vectors for diseases. So sometimes if a tree is broken or damaged, insects like to feed on those wounds. Insects can then bring funguses along and introduce those to trees. So we do expect forest health to change going forward, but that doesn't mean we're not going to have trees. It doesn't mean we're not going to have forest. And a lot of it is about being proactive versus reactive. It starts with things like this outreach. So being interested in what is happening and what you can do, and how you can promote climate resiliency. So the biggest thing is, when you can, reduce stress on your trees. Sometimes people call me out and they're like, my tree just suddenly died. This oak was so healthy last year and it died, and I think I have this like crazy disease. And I come out and they park their RV about like 3 feet away. So it's compacting on the roots. It's bringing additional stress to that tree. So when we can, reducing stress on trees, early detection of pests and diseases. So the sooner we know that we have a new pest, the easier it is for us to take action against it. There are some things that we are able to, I know that it sounds really negative when I've just talked about all these horrible things that impact trees, but there are things we can actually eradicate from our landscape. In the Worcester area, we had Asian longhorn beetle introduced, and that is a pest that we are able to eradicate. So for the last 12 years, we've been working in cooperation with the USDA on that project, and we've gone from finding thousands of infested trees in 2010 to in 2021, we found a single infested tree. So we are making progress in that way. And then managing for healthy forests. And I know it can sound a little bit counterproductive, but sometimes you do need to cut trees and remove trees to make a healthier forest landscape. Our forests have grown up heavily influenced by human development. The structure of them is not always the healthiest. They are too crowded. They are too even aged. You really want a diverse forest. So diversity is the healthiest forest. So diverse species, diverse age structures, And the forests we have in a lot of our state are not meeting that. They're very monocultured in points, and tend to lean towards being older trees. So cutting forests to increase space, allow younger generations to grow up, give some of these overstocked trees a little bit space, things like the white pine. A way to manage some of the needle disease is actually to thin your trees out so that you only have a handful of mature pines that have more space and airflow around them to decrease those fungal pathogens and allow more understory to grow up and have more diverse trees. So it's not just a continuous stand of white pines. And then planting trees. And I know there's been a lot of questions from this group about planting, and I'm going to share in the chat some good resources from our urban forestry program on selecting trees and planting trees in your landscape. So I will say the first thing is, even though trees might be found in your forests out in your area, that doesn't mean they're always going to be the best urban tree, because our urban forests are a whole different thing. The soil's disturbed, the sites are changed. So it's really about choosing the best tree for the site. So choosing a tree that's going to be the right size for the site, the right growing conditions for that site, and also what you want. So if it's a tree that's next to your house, it's going to be a tree that you're going to want to look at every day. And it's kind of important to know your site history, what kind of soil you have, how wet or dry it is, what the limitations are. Do you have power lines going over, things like that, but also future needs. If you know that within a few years you're going to have to change something about the site, not wanting to put a longer lived species or something that might be more useful in the short term. And you really want to avoid trees that are nuisances. So things like tree of heaven, people in the 1800s loved it. They thought it was beautiful. They called it tree of heaven. It is a invasive tree. It lives in cracks and crevices. It grows behind dumpsters. It grows out of rock walls. It is not a great tree to plant. So avoiding trees that in themselves are invasive species, and then avoiding trees that are susceptible to other invasive species. Like I wouldn't recommend planting things like ash, because we do have emerald ash borer. At this point, I would also recommend holding off on planting beech until we know more about beech leaf disease and how it'll impact trees. And I know there's a lot of questions about carbon sequestration and native versus non-native. And generally, planting native is usually a better choice. They are suited to our environment. They are suited for our ecosystem. But sometimes if you have a really disturbed urban site, it might not be suitable to some of our natives. And it might be better to choose a species that is not native to our ecosystem, but isn't invasive, that is able to complete those same ecosystem services and functions that native trees can usually do, but wouldn't be suitable to that site. So most of the time, native trees are a little bit better. And usually things like carbon storage on the single tree front, it doesn't make a huge difference. Any tree is going to be pulling in carbon and storing it in its wood resources. And there are differences based on the different types of growth forms of trees and how trees grow. So like a hardier, faster growing deciduous tree is going to store more carbon just because of what it is, but it doesn't mean that other trees aren't storing carbon and aren't valuable to the ecosystem. And also the handful of tree decisions you make aren't going to make a huge impact. It's more of a forest landscape of actually maintaining trees on a forest and maintaining trees on your landscape globally that kind of make that bigger impact. And I just want to say, I know that through my talk, I feel like I get kind of down. I tell people a lot of the bad news, but we have trees. We have amazing forests here in Massachusetts, and we've had invasive species for a long time. So this is the Quabbin Reservoir when it was being filled in the early 1930s, and they cut a lot of trees. There were not a lot of trees there at that point. By this point, we already had gypsy moth having huge outbreaks through this area. So these forests grew and developed after being heavily disturbed with invasive species already there. And this is the Quabbin today. It is very dense forest. We have a lot of mature trees. We had a lot of different microsites and little micro habitats there. So we still have gypsy moth. It's still a problem, but we still have plenty of oaks there as well. So it isn't hopeless. There are negative things to our forest. There are things we are working to mitigate that, but we will always have trees on our landscape. So this is all of my contact information, and feel free to email me, give me a call. Our mass.gov, if you go on mass.gov, if you forget all my information, forget everything. You can also just Google DCR Forest Health. You can go on the mass.gov site and search in the little search bar for any of these insects or diseases or questions, and it'll pop up our webpage. And on the right side, there's always contact information. Sometimes it's me, sometimes it's someone from my team that is more knowledgeable in that specific area. And you can always feel free to reach out to them too. So I think we have a couple minutes if people have more questions or discussions.
Nicole, thank you very much. That was a lot. You and your small team are incredibly busy and doing a lot. So thank you for what you're doing, and thank you for sharing it with us. One question to start, if I might. The biocontrol critters you use, I assume you sort of follow them in terms of, I mean, there's always the idea of, is there unintended consequence of introducing something, and how do you sort of keep track of these guys and seeing if they're doing something they shouldn't?
So a lot of work. So, I mean, in the early 20th century, gypsy moth biocontrols, they used to just bring over anything that they thought was going after it and just throw them out in the landscape. And it was not good. There were a lot of unintended consequences. The way they do it now is much more rigorous. So before they even bring them here to the United States, they do a ton of research over in the host range. For a lot of the biocontrols that we are utilizing now, their host range is Asia. So they find them out in the field there, they do lab work there, they bring them back to very secure facilities here in the United States, and they make sure they test them on all sorts of our natives, our close species, to see what they actually do. They also do field-based testing on small scales before they reach it. So they make sure they are very host specific. They make sure they are not carrying any funguses, bacteria, diseases, viruses like that onto our landscape as well. So it takes many years before they can actually get released in the forest. So they're doing a very thorough job at the USDA.
Thank you so much. Over to you, Peg. Do you see any other questions? Do you have any questions, or anybody else?
I don't see any questions right this moment in the chat, but I do have one question, and maybe you can give us, I know you gave us a couple of references there, but do you have any suggestions about people who want to plant? For instance, we have a group here in the Cape Ann area that are planting a cultivar from elm that is a disease-resistant elm. And there are a number of other restoration efforts like that. Do you recommend any others in particular that would be beneficial here in the Northeast, at least in Cape Ann?
I know that the elm ones are really great, and they also there are chestnut restoration efforts that are pretty cool too. We are still a few years away from some of our ash resistant, but they are starting to do rearing and things like that. So hopefully within the next few years, we will have more widely available cultivars of those. It is a lot of effort, it is a lot of work, and it can be, I know, a big deterrent for some people. They end up being a little bit more costly than some of your other trees that you might be planting. So it is hard for communities to justify that cost sometimes. Okay,
and there is one question here from Betsy: how to deal with all the dead wood in the forest? And that we do have a fair amount of that right now.
Yeah, you guys have a lot of dead oaks, unfortunately. And in the forest themselves, having dead trees is part of the natural processes. And you'll start to see, I've really started to see in the last year, a lot of the dead oaks, you'll see a lot of mushrooming and funguses up the side. So the natural processes are going on that'll break it down. Having dead trees doesn't increase the overall like fire risk. The fire risk in our area is more dependent on weather conditions. So having more oak doesn't necessarily make us more at risk, but it it does provide habitat to some of our wildlife, and in the forest they'll be here for a while, they'll keep falling. Areas where they're along like roadsides, along trails, along parking areas, it is useful for groups or landowners to drop those trees. So even if you can't remove them from the site, to at least drop them so they're not a hazard is what I usually recommend.
Great. Okay, we have 3 more hands going up here, and I'm not sure what the order, but I'll go in my order here. Susan, maybe you can unmute yourself. Susan Hoeg.
Yeah, hi. We have a huge beech tree in our backyard. If it starts to get that disease, is there treatment for it? Can I have it sprayed, or how do you treat it if you see it getting infested?
So there aren't any, I know this is not a good answer, but there aren't currently any approved treatments. There have been researchers out in Ohio with their Arboretum out there that have been doing research, and it does seem like phosphite treatments will be useful, and emamectin benzoate may also be another treatment option. They've only done small scale studies at this point, so it's not quite to the level that they're like, yep, this works. So I update information on our webpage. So on the mass.gov site, we do have information about beech leaf disease. So if I hear more, I will be posting it on there and sharing with other groups. But at this point, there's not really a treatment. It's just identifying that you have it and reducing other stressors on your tree.
Thank you.
Thanks, Nicole. Jock, you have your hand up.
Yeah, Nicole, thank you very much for an incredibly detailed presentation and discussion. I was heartened to hear that when you said that you can tend to get down in the dumps when you see some of these trends and changes, but you're really not you're not necessarily losing sleep. In the area of actions that we could all take, in summary, I don't know how long you've been collecting the data that you've been showing us in terms of the infestation of insects, et cetera, but how much of what we're seeing is attributable to man-made causes, climate change, things that we can do something about versus just sort of stuff happens. Things change over time. The migratory habits of some of the insects change, and I don't know how far back the data goes, but is it man-made? Is it climate change, or is it just nature?
It's definitely a mix, because there are things of just our forest aging, and I mean, trees, they don't all survive, so trees do die, and you'll see more increased mortality events as you get older, even age stands. But climate change is having a noticeable impact on our forest health. It has some direct impacts by the stress of like droughts and storms, and then a lot of these indirect impacts by altering these other species, these funguses and insects. And it is, so as part of our state, so every state has to develop a forest action plan to kind of say, like, in the next 10 years, this is how we want to help our forests. And the last one we just did was in 2020. And a big part of it is about climate change, because we're identifying it as throughout our forests, it is a problem now, and it is going to continue being a problem going further based on the projected trend. So it is definitely human influence, some of it.
Okay, we have 2 more. Nick Anderson next.
Hi, Nicole. Thank you so much. My question is, in our forests where the oaks have died from the aforementioned moths, most of the composition that I've seen, or a lot of the composition that I've seen, is gray birch, sweet birch or black birch, big leaf aspen, and quaking aspen. And I wonder if that is a species combo, often growing extremely close together. If that's a species combo that you've seen before, or that seems auspicious or problematic, or is familiar, or it's just totally novel.
A lot of the times we'll see the birch, and then I think for you guys, on on the coastal areas, you see some of those, you'll see a couple other species that I think aren't like quite as common mixes in some of the central interior stands, but it is common to see those in like these openings and mixes. There are challenges to with some of our oak regeneration because of our deer populations. So in areas where we're having more development, our deer population increases. We've also just had a decrease in hunters and kind of interest in that component. So deer like to eat a lot of our oak seedlings too. So we do see sometimes reduced oak regeneration in areas where deer populations are really high. But some of these other hardwoods will come up a little bit faster and do a little bit better compared to that pressure.
Thanks, Nicole. And we just have one more from Peter, and we'll let you close out, Peter.
Yeah, and it's a related question. It's it sort of, are there, for this particular area, what species of oak would you recommend that we try and plant and then fence in from keeping the deer off? But are there particular species you'd recommend of oak for this area?
It depends on the site. You guys actually have like a more diverse oaks. So you'll have some sites that'll have that northern red oaks, but you'll have more sometimes black oaks and scarlet oaks out in that way too. And then pockets where you are seeing eastern white oaks as well. So it's a mix. You'll see some areas too where on the coast, you'll have the more scrubbier scrub oaks and swamp white oaks instead. So it is really site specific.
Well, good.
And compared to some of the interior stands, it's a little bit easier of an answer.
Well, great. We've got options. Listen, thank you so much. This was a lot, and I really appreciate your sharing all of this and your openness to having people follow up with questions. We really, really appreciate what you're doing, and thank you for being with us and for being open to questions.
Yeah, thank you guys for having me. Yeah, and
Our
please
pleasure.
don't hesitate to reach out.
Reverend
just-
Sue?
Yeah, just to, and so thank you, Nicole. Thank you, Peter and Peg. Just a commercial, April 4th, the 11th at 11, ring those bells wherever you are to call it awareness to our climate emergency. Also next Tuesday at 4 o'clock, we are going to return to looking at the Bright Action app that has helped us figure out how we as individuals can reduce our carbon emissions. And then this is not related to creation care, but I'm going to tell you about it anyway. On Good Friday, those of you who celebrate Good Friday, we're going to do a peace walk for Ukraine at 1 o'clock. Down at the Fisherman's Memorial. It's also a fundraiser for World Central Kitchen. So, and then finally, Earth Day, I should tell you about that too. At 11:15 at Good Harbor Beach, there's going to be a beach cleanup, followed by a interfaith gathering. We're going to call in the directions, have some poetry, do some pretty groovy things out at Good Harbor Beach. Reverend Lisa from St. John's Episcopal and I will be leading that on Earth Day. So thank you everyone for being here, and have a great night.
Okay.
Thank you.
Thank you.
Well done. Bye.
Thank you,
Bye-bye.
Nicole. Wonderful. Thank you.